Qué bueno que están acá. Bueno, esta es nuestra última actividad de la conferencia. Muchas gracias por haber participado. Y ahora voy a cambiar a inglés, because our next speakers speak English, so I'm going to switch. The next keynote will be Max Kuhn. He works as a software engineer at POSIT. He leads the Tidymodels team. And on 2020, when we were supposedly organizing the event here, we decided to invite him, but the pandemic and stuff, so we have to postpone the invitation. And at that moment, when we decided to invite Max, we looked at our list of cool people that do awesome things, and he was there, so let's invite Max. And in 2023, when we were absolutely sure that we were going to hold the event here, we invite him again, so let's come to Montevideo, and he didn't answer our email. So we moved him from the cool people list to the blacklist for a couple of weeks until we discovered that he actually answered our email, but it went to the spam folder. And we solved the issue, and now Max is here to talk about the Tidymodels universe. So thank you, Max, for coming.
Okay, you can hear me okay? Yeah? Excellent. Thanks for sticking around to the end of the conference. I appreciate it. Now, I've been using, you may have noticed, we've been using Google Translate during the sessions, and I've realized if you're going to do that and translate it to Spanish or Portuguese, I will speak, try to speak slowly and clearly. I'm saying this because, let's see, my favorites so far have been, so I wrote a package called Carrot. And is anybody in the US, if somebody calls you a Karen, has anybody ever heard that before? It's kind of like a really mean thing to say. And it translated Max Kuhn's Karen package. And so that was that. And then ggplot got translated to, was it like JP Plop 2? Yeah, so that's what we're going to call it from now on. We're going to send it to CRAN, break all your dependencies. It's the new name. All right, so I'm here to talk about Tidymodels. We did a tutorial on this. Hopefully it won't be too bad if you were there. And hopefully it'll be good for people who weren't. So if you want the slides, I thought it's at the bottom of the slides, but a little bigger font here if you want to see it. My GitHub handle is Topepo, so it's 2023 Latin R. So at first I'm going to tell you why maybe Tidymodels and actually Carrot too exist. R is very, very, very good at many types of modeling. It's always been stellar at things like mixed models and hierarchical models, survival analysis, and there are just so many things that it does in terms of modeling. For a long time, it's had quite a long history of having really good predictive modeling and machine learning models. So there's a lot of really good things if you're doing modeling in R. You know, the formula interface, if you ever use that, like y tilde x, that's been around since I think it was like 1982, believe it or not, in the S language. And so all the things they did back then in the S language have really carried through to R, and so we've always benefited from having really expressive ways to do modeling. And it's also pretty much had cutting edge models. So things like random forest, the first real implementation of that people could use that wasn't Fortran was built in R. And so a lot of times people who do modeling, they might use R as their first sort of like prototyping language. So outside of like deep learning and some other things, especially if it's tree-based models and regularized models, I think you see things in R before you see them anywhere else. And if they're not there, the last really good thing that's pointed out here is R, and the S language originally was built as an interface to Fortran wrappers, if you can believe that. So for quite a while in the DNA of R and S, it's always been really easy to take things that R doesn't do well and do them much faster or better in C or Java or Python or whatever it is. And so, so there's quite a lot there to love and use, and you can be very effective with it. But there is a downside, and it's mostly about consistency. And so, you know, some examples that I'll go into a little bit more detail come down to things where I think package managers, and I'll include myself in here early on, I think when we write packages, we kind of write them for ourselves usually. And so a lot of times the scope of the package or the things it can do or the things that it doesn't do, a lot of times is largely informed by the things that are important to us at the moment. right? So Iwei, who we work with, once said, I really want to eventually write a package that I love that nobody knows about, right? And so what happens sometimes is somebody writes an interesting modeling package, but there's a lot of things that other people might want to do that maybe they don't know about or haven't thought about, and it doesn't really get implemented in the package, and that can make it kind of difficult to use sometimes. So just some examples of the consistency problem. Let's say you're fitting a classification model, and let's say you have like 2 classes, like yes or no, and you want to get the class probabilities back. You might start off by fitting like an old school like linear discriminant model. And the standard way of doing that is to take that model fit and put it into the predict function. And if you use that particular model and you want to get the probabilities back, you don't really have to do anything. You can just use the predict function and give it your object. But for a lot of other models, you have to say something like type equal. And this is just this slide is usually a lot longer with all the options you have. But there's type equal response for logistic regression. Sometimes it's prob, which is the one I like. Sometimes it's posterior. Sometimes it's probability. So when I was doing this for a living, like before 2000, I'm old, this is very, very frustrating because you had to remember all the minutia of every particular package that you would like to try, and that was kind of a pain. The other thing is, R generally has 2 interfaces to models. There's the formula method that I discussed, and then there's also what we just generally call like the non-formula method, and that's where you have predictors in some matrix or data frame X in your outcome and some vector or matrix or whatever Y, and then you'd say the function and give it X and Y. And sometimes you want one or the other, or sometimes you might want both, depending on how your data come in and things like that. And so here are 5 fairly popular machine learning or modeling packages, and let's pick GlimNet. So between the formula method and the non-formula method, raise your hand if you think it has the formula method. Okay, thank you. Raise your hand if you think it has the non-formula method. Okay, wow, it's, okay, 1 versus 3. Thank you, Hannah. Well, here's how this all shakes out. So if you're using GlimNet, it actually only takes matrices, which is kind of a pain because if you have any categorical predictors, it's your job to turn that into indicator variables. If you want to transform a variable, that's your problem. The formula method kind of does that automatically for you, and then you have to, when you make new predictions, give it a matrix. And it's very limiting, so if your data is not just a bunch of numbers already, that you do the work. So we get around that, but it is what it is. Ranger's a really good random forest package. It's pretty fast and it does a lot of things. And it has both the formula method and the non-formula method, which actually is not correct. You can use a formula or use X and Y. The problem is it's all in one function. So they have a function that have arguments formula and data and X and Y, which is kind of weird, but we can get there. Our part is a decision tree package, very old. It has just a formula method. I long ago put in an issue to get the non-formula package, or non-formula interface, and the maintainer sent me the sources and says, you should maintain it then. I am not maintaining it. And then survival is for survival package. It is also formula only. And then our old friend XGBoost, which a lot of people love, not only does it not have a formula method, you have to convert the data to a special sparse matrix format. You append your outcome to that, and if it's a classification model, you have to convert your outcome to zero-based integers. So this just gives you a sense of these are all used quite a bit, all these packages. So sometimes you're doing a lot of work for these packages, and so this isn't really something that we like people to deal with. So I used to work with engineers a lot, and some of the sharpest and most functional engineers I worked with were called systems engineers. So like you think about your phone, and there's a whole engineering crew at Apple or the people who make Android phones that are battery engineers, right? And then you have engineers that work on the screen to optimize that and the antenna. And you have all these groups of engineers, and what a systems engineer does is make sure all that stuff works together, that one thing's not taking too much power so the other thing can't work, and so on. They just make it all happen, not at the end, but along the way. And I feel like I realized maybe like a week or two ago that my professional life mostly has been spent as what I would think of as a system statistician. Because we have a lot of packages that do really interesting things and we want to use them, but they're not necessarily made to be consumed, to be used somewhere else or in a different context than the original author intended. So that's a lot of what we do. That's a lot of what I've been doing, and then that is absolutely the sort of the goal of Tidymodels. So our job is to really make R less frustrating, but really it's really not that bad. It's very functional, and with a few extra tools, you can get very, very far and build very effective models. And I say here, like, we usually talk about predictive models and machine learning. Tidymodels can do pretty much everything. We have packages for hierarchical models, now survival models, and so on. So it's not just like a machine learning library. So you've probably heard of the Tidyverse. I know that's kind of a ridiculous thing to say, but I've done this presentation where people looked at me funny. And the Tidyverse is built to have packages that work really well together, to have a common sort of design goal. The naming is very similar, and it's very, very thought out in how you interface with the software, probably more than anything else I've ever seen. And when Hadley first started working on that, he had like these goals that are listed here. Like, don't make a new data structure that somebody has to learn. Try to stick with data frames if you can. Probably the most important one here is designed for humans. Like, can anybody raise your hand if you know the function name if you have a matrix and you want to invert it? Does anybody know what the function name is? You first. Solve. There's no inverse function, right? That's not designing for humans. So, it's those kind of things. We want to make things obvious for you. We don't want you to get like a result back and be surprised that, wait, why is it in a list and not in a data frame, that kind of thing. So when we think about like designing for humans in terms of modeling, it's a little bit different what they do in the Tidyverse. But at the end of the day, we want you to enjoy programming and not be constantly frustrated by it. So in some of the things that we do is we try to name things and optimize them for autocomplete. So if you're doing model tuning, all of our function names that do that start with tune underbar, and then if you're in RStudio or VS Code, you can just tab, and then you get the whole list of things. Whether they're grids or tune objects or things you can extract, like we try to make function names as consistent as possible, Hannah, and when I don't, they fix it. So the other idea is this notion of tidy data. There's a link here to one of Hadley's paper that really every variable should be in a column, every row, or every observation forms a row. That's a little bit weird for us sometimes because sometimes we have records that have multiple sort of sub-records. So if you're a patient in a clinical trial or you're being followed longitudinally, like the patient is really the observation. They're like the independent experimental unit, and they might have multiple rows in the data set. So some of this we have to deal with a little bit. But our idea is like we want to create modeling packages that work well together, that do a lot of things, and that you know when you start using them, even if you haven't used the other parts of it, you'll already know what to expect when you get there. So I've been thinking about modeling for a long time, and if you were at the tutorial, I mentioned that in the process of having like a career doing modeling before coming to or posit, you can edit that out, right? There were mistakes were made. You learn a lot along the way, and so a lot of that informs how we design our software. So the first bullet point there is type equal prop. That's just remember that one, right? So when you use our code, we'll make the translation for you for whether it's probability or posterior or whatever. If you want to use the formula method or not the formula method, we'll handle that for you. So we don't want you to have to worry about that. Another thing that's important to me over the year is resampling and empirical validation. That when you have a model and you want to know, if you want to get something out of it, you should be able to quantify its performance, hopefully using something like cross-validation of the bootstrap. I've sat in a lot of presentations where people present results with like logistic regression and how important it is that this p-value is for the interaction is less than 0.05, and then you ask them what the accuracy of the model is, and it's like 60%, and you're like, okay. So there's a lot more to qualifying and validating your model beyond just doing predictive modeling. Another thing that we sort of do in Tidymodels is it's designed with sort of some hidden guardrails. At least in machine learning, a lot of the problems that occur that you don't necessarily know happen until you get new data, those are the result of people using maybe the wrong data at the wrong time for the wrong thing, or using it for multiple things. And so you sort of have to go out of your way in Tidymodels to sort of use the data inappropriately by accident. Yeah, and so we want people to also be able to use the infrastructure to make your own packages pretty easily. And we want to encourage people to do things that they necessarily couldn't before. Because I've heard a lot of people say, yeah, that is probably a better way to do this, but I don't know how to use that software. I don't have a license for that, or it's not been written and I'm probably not going to write it. So we want to also sort of, like the next slide has the phrase leveling up. Does everybody know what that means? It means like how can I improve me or my tool set to get more out of what I'm doing. And just some examples of that is, a lot of times we have variables like predictors in our data, and we use a model that can't handle them as character data, because they're categories. And so we have to convert them to indicator variables. There are a lot of different ways you can do that, and a lot of times there have been methodologies out there that people just didn't have available to them, or the package wasn't easy to use, and so on. So just as examples, there are things called effect encoding methods that can be very effective in certain situations. Feature hashing is an excellent tool if you have categories that have maybe like thousands or millions of levels and things like that. Also multiple choice predictors. I've had codes laying around in scripts for years that take, if I had a model and a predictor was like, what languages do you speak? Some person might have one, somebody might have four. And so having like a way to deal with multiple categories is really helpful. So we're trying to institutionalize as much of that as we can in Tidymodels so you can just use it and not have to carry around your little bits that you've been doing. I had these slides already written before I saw Di's presentation, but also some modern dimension reduction methods like UMAP, which he showed, and these fancy name things like manifold-based multidimensional scaling and things like that. So, there are things we see in papers and all that, but we don't necessarily have the tools to fit them, and so we want you to try to use them. And even if maybe they're not effective, maybe they are, but having the ability to even try that is important to us. There's other things like a lot of different imputation tools are out there, so we just want you to be able to use this stuff. So, if there's something like, yeah, I use this all the time, but I can't find it anywhere, just come to our repos and put in an issue. We'd like to hear from that. All right, so if you want to learn more besides this, there's three main resources. There's tidymodels.org. We spent a lot of time on that during the very beginning of the pandemic, just sort of optimizing that, putting a lot of articles in there, searchable lists of functions, a really nice sequential set of getting started articles. Julia Silge and I wrote a book on Tidymodels. You can get it from O'Reilly, or you can just go to this link and take a look at it. That's very helpful if you want longer form documentation. And also, some of you may know, after the other day, we keep all of our training materials in the same place. We keep all the old versions, so if we change data sets, you can always get to the version that you used. But you can go to workshops.tidymodels.org, and there's a lot of training materials there. And all this is licensed in a way that you can use it in your classes or for whatever you need. Okay, so let's look at some code maybe. Like the Tidyverse, we have like a meta package. So if you load Tidymodels, you see this big amount of output you get back. We load things like dplyr and ggplot, which are not part of Tidymodels, but you're probably going to want to use those. And also, like Tidyverse, we list these conflicts. Things like dplyr has a filter function, but the stats package has a filter function. The one that, if you just type filter, the one that you get is based on which package was loaded more recently. And so one thing that we added here is this thing at the very bottom called Tidymodels prefer. And what that does is it has uses a package that Hadley wrote called conflicted that manages these conflicts. So after running this function, assuming you want to use dplyr in Tidymodels, it will sort of default your filter no matter how it gets loaded to use the dplyr one. So you don't have to use this, but if you're sort of tired of dealing with these, I have the wrong function from the wrong package, this can be a big help for you to resolve that. All right, so I have some example data. It's a little bit more than 10,000 data points, and it's something about restaurant deliveries, like food deliveries. So basically we have a time period from when the order was put in to when it was delivered. There's a few variables. There's the order time is like the hour, 0 to 24. There's a day of the week, so it's a factor. It's Monday, Tuesday, Wednesday, that kind of thing. There's distance. And also there's 27 pre-made sort of indicators. And this is like the result of like a multiple choice thing. These are counts of the things that were ordered. So like item 3 might be somebody ordered an iced tea or something like that. So we want to take this information and try to predict how long it would take you or me to get our food at home or wherever it's being delivered to. So it's a fairly decent sized data. It's 10,000 data points. There's not that many variables. The first thing we'll do is we'll look at the outcome. I should say, if anybody here does survival analysis, you're probably wondering if any of this data is censored. This is all complete data. Censored means, if I put an order in and it's 5 minutes after, I don't know when it's going to get here, so I don't know the actual delivery time, but I know it's at least 5 minutes. And so these are all complete values where they've actually had the delivery and they know what the time was. And you can see it's right skewed, which is pretty common with time data. It's non-zero. Ranges from maybe like 12 to around 60. It's right skewed with a little bit of a mode here. So one of the things we might think about is, do we do anything special about this? One thing you might think about doing is logging the outcome and then doing that. I'm just going to keep the outcome the way it is. And the only other thing I'm going to do with it special is I'm going to split the data up. I'm going to split it into a training set, a test set, and a validation set. And the validation set is sort of like a test set, but you can use it along the way to figure out how well your model's using or how well it's working. The test set is really at the very, very end when you want to just validate what your results were. So when I do that split, what I don't want to happen is I don't want to have all of these sort of like outlying extreme data points end up accidentally in the test set or the training set. So when I use this function in Tidymodels called initial validation split, it'll put 60% in the training set, 20% in validation, and the remaining 20% in testing. And what it'll do is it'll do that three-way split by chopping this distribution up into quartiles and doing the split in each quartile of the data and then recombining them together. So the distribution of this outcome in all three of those data sets should be very, very similar to one another. So we can make sure, by doing that, we can make sure the distribution here looks the same across the training set, the test set, and the validation set. So in the code here, we get the split, about 6,000 data points for model fitting, about 2,000 for validation, and about 2,000 for testing. We try to make our function names as obvious as possible. So if you have the object that has the information about splitting, you want to get the training set out, we're going to name that training for you. And validation is the function that brings back the validation set. So this takes a split, and you get a data frame out of here with the appropriate 6,004 rows, and so on. Now, a lot of times I talk about resampling, like cross-validation, the bootstrap, and those are ways to use your training set to get good estimates performance that are not like overly optimistic. And I'm not going to be doing cross-validation or resampling or the bootstrap or something like that. I'm going to use my validation set sort of as like a single resample. And to put that sort of into the Tidymodel format, the same way you would get the same format as cross-validation, we'll do a little extra step here and take that split object and pull out the validation set in a way that we can consume this by some of the functions we'll use later. Okay? So, I think I see this on one of the slides upcoming, is one of my college professors said that the only way to be comfortable with your data is to never look at it. And so, when you look at this data a little bit, you look at the time of the order, and clearly the delivery time increases with that, and it's maybe not linear. So this is something, if we're going to fit like a linear regression here, we need to think about, that there's a nonlinear effect here. I use GM Smooth. And what GM Smooth does under the hood is it uses something called a spline function. And what a spline does is it takes the original time variable and sort of expands it into these kind of weird extra columns. And those extra columns are the ones that are used in the linear regression. So this smooth line here that you see here is the prediction from like a linear model that uses maybe 5 or 10 of these extra nonlinear terms based on the order time. That'll be relevant in a minute, so that's why I'm lecturing on GM Smooth. But this is something we need to think about if we're going to fit like a linear model. But if you look at it a little more closely, it's actually a lot more complicated, because it turns out if you look at that same trend and estimate it differently for the day of the week the order was made, it's quite different. That Friday and Saturday have a very, very steep nonlinear curve, whereas something like Monday, it's a lot more blunted. So if we just did this and put it in the model, we're going to underfit, because it depends. And that's what a statistical interaction is when you have two predictors and their relationship with the outcome, they depend on one another. So in this case, just knowing the day of the week is not enough, and it's also not good enough to just do this nonlinear function of time. You have to sort of consider them together, and so we'll do that in just a minute. All right, so we have this amazing package called recipes, and what it does is it prepares your data for modeling. And you can start off by just giving it, any data set, but we'll use the training set here. And we'll use a formula. And all it really does is, what the formula does is it says things on the left side of the tilde are outcomes, and everything else represented by the dot is a predictor. So at this stage, all the recipe does is says, okay, what's the role? Is it a predictor, is it an outcome? And it looks at the actual columns, and it measures, like, are they category, are they factor, or strings, or ordered, or numeric, or integer. So it sort of like just investigates the data and remembers what the columns are. Now, the way recipes works is it's a little bit like the formula method or model.matrix in R, but with a flavor of like dplyr. In dplyr, you would keep piping in things that you want to do to the data until you have it the way you want it. And the recipe works the same way. We're gonna pipe in declarations of like, hey, I want you to log the data now, and I want you to do this with the data. So the first thing we'll do is we'll create indicator variables for the day of the week by using a function called step dummy. So those indicator variables are sometimes called dummy variables. So we're not mad at this variable, it's just like step dummy is the name of it. And so all these things we're gonna do and pipe in, they're called step functions. They all start with step underbar. And then the first argument in all of them is what variable should be affected by this. And you can use any dplyr selector here like you would with select. You could put in like everything minus something, and starts with or whatever you want. But at this point, what you're saying is, I want you to take this column, make indicator variables out of it, then take it out, and then leave the resulting indicators in there. There's a lot more you can do besides just dummy variables. Take a look at this chapter in the Tidymodels book. It's something that we're very strong in for this package. Oh, and one thing is, don't you hate what base R does is, in this case, it would say like order day, and then just take the level and just jam it up next to it. And it's like the worst aesthetically thing ever. So what we do in step dummy is you get to choose a delimiter, and by default, it's underbar. So the resulting Friday indicator would be order day underbar FRI. So you have some control about how it looks in your model results too. All right, remember that though, that it's going to be named that. Well, what you could have done is recipes have a lot of extra selectors that you can just use here. And you can choose variables not only by their type, like are they character or factor or things like that, you can also choose them by their role. So if you want to do something to all the predictors, whatever might be in there, you can just say all predictors instead of like listing them all out. And so there's just a lot here that you can do with, and it's kind of a strong thing that we like about this because generally speaking, there are some recipe steps that will get rid of variables. So if you start writing specific variables down, especially late in the recipe, you may have actually eliminated them, and it might cause an error in the recipe because you're saying do this to variable X, but variable X isn't in the data anymore. So we encourage people to use very generic sort of selectors here. All right, so what's next? We have a lot of indicator variables. I think I call them item, and they're counts. But there might be like one of those items in the training set where it just so happened they almost never get ordered, and the training set might have all zeros in it. That's not a big deal for some models, but for other models, it doesn't like having a column of all zeros. So we call that a zero variance predictor. So what this would do is when you use this recipe, it would look at your training set, it would find any of the predictors. I used all predictors. So it would search those and look for anything that has any column that has one unique value, and it marks that as you should get rid of that. And so this is a little helpful thing you can do. We also have something for what we call near zero variance predictors. Imagine you have like 1,000 rows and you have 999 zeros in a single one, right? That's maybe not what you want in your data set. So we have some other ways of doing this that are a little more general. All right. So then what we're going to do is we're going to do splines. We're going to do exactly what GM Smooth does. We're going to take our original column of the hour that the order came in, and we're going to generate as many columns as we want to make it nonlinear. And if we add 100 columns, it's going to be a really wiggly line. If we add very few columns, like 2 or 3, it's going to be a relatively smooth line. And so we don't know how many to add. The typical parameter for that is called the degrees of freedom of the spline. And I'm just going to add 5 columns to represent that nonlinearly. Why 5? I just picked it out of there. It's not, I mean, looking at this, it's not like a super wiggly point here or a relationship, so 5 I would probably do fine. But we have a variety of other basis expansions. There's a lot of different ways you can do splines. There's polynomial expansions. So there's quite a lot of ways you can represent a column in a nonlinear way to the model you're going to use. But you might be saying, like, I don't know about 5 though. I'm kind of stuck on that. You don't have to actually pick it. You'll see later that you can actually tune these options. So I can give it a non-value of this function called tune, and all that does is it just marks it to say, like, hey, later on, you're not going to be able to do this recipe until you know what this is, but we'll do it in a way that will search over different values of that parameter to figure out what the best performance is. So you can mark pretty much anything in here as being tunable, and then just optimize it however you want to. So here we are. Remember, we have dummy variables that are like order, day, and the factor level. When we make spline terms, the way they're going to be named is they're going to be like order time, underbar 1, underbar 2, underbar all the way up to 5. So if you want to add interactions, and I looked to see if you can do this in base R, and you kind of can. You can make interactions between a factor and a spline expansion, but you can only do it for one variable because it gives the splines the same names if you did it with a second variable. So we can do it for one variable. We can do it for pretty much everything. And the way we would do that is something called step interact. And then you can just give it whatever interactions you want to. And those interactions could use starts with or any dplyr selector. So we know all our indicators start with order day. We know our spline terms start off with order time. And that will let our spline terms, those relationships, be different for day of the week, which it looks like they are. So this is something that would be a little bit hard to do with base R, but it's actually pretty simple to do it this way. All right, and then the last thing we'll do is, just for kicks, just to show that you can do it, is there are some models like GlimNet or k-nearest neighbors or something like that, where if you don't, they're going to want all the variables in the same units. If you think about like computing a distance, if something's in like square meters and another thing's in like low counts like 0, 1, 2, 3, those aren't in the same units, and the variable with the larger numbers is going to dominate the computations. So what step normalize does is, with your training set, it estimates the mean and variance of every column, and then when it goes to process the data set with the recipe, it subtracts the mean and divides by the standard deviation, so everything has like a standard normal distribution. And we're going to use GlimNet in a minute, so spoiler alert, we need to do this for it. All right, so this is the things we do to our data before we put in the model, and then how do we make the model in Tidymodels? So what we do is the package that does that is called Parsnip. Parsnip has different model functions. So it's sort of almost like a 2 or 3 step process here, is you say what model you want to use. So the first thing you do is you say, I want to use linear regression. And all that says is my outcome's a number, and my predictors should be like slopes and intercepts. That's pretty much all it says. It doesn't say how you're going to do the estimation. It doesn't say what those values should be or whatnot. There's different modeling functions. So like a nearest neighbor model is very, equation-wise, like very different than linear regression. There's model functions for random forest or decision trees. There's a whole host of them for time series models and so on. So step one with Tidymodels is tell me what you want to do. Like, what is it that you want the end result to be? And then the second thing you say is, well, how should I do it? And the how that we do it is called the engine. And so the default engine for linear regression is LM, but I'm going to show it here. You would just pipe into that linear regression function, set my engine to be LM. And we could do that, but maybe not. We could also use like TensorFlow. So maybe you want to use some sort of weird objective function through TensorFlow where you have a lot of data and you want to batch it. You can do that too. Or if you're more of a torch person, we have a torch modeling package called Brule. You could do that. If you have a lot of data, maybe you want to use Spark. You might have your data in a Spark cluster, so you can fit that model using Spark. If you're like me and you're really into Bayesian models, you can fit a linear regression using STAN. So that's not doing maximum likelihood, it's doing like Bayesian estimation using priors and all that stuff. The thing we're going to use is GlimNet. And GlimNet's a really nice model. The package will be a little bit frustrating, but it's an excellent model that can handle a lot of different things. It automatically does feature selection for you, and it has a lot of niceties to it. So we've set our engine. We're ready to go. It does have some tuning parameters, and these tuning parameters are things that you need to set up front. You can't directly estimate them like you estimate slopes and intercepts. You have to say up front what they should be, sort of like that degrees of freedom. It's something that matters a lot, but there's no equation that tells you what the value should be. And the first one there is called the penalty. So GlimNet is a regularization method. It penalizes your coefficients. And so usually that penalty is between 0 and, I don't know, like 1. So I'm going to just pick 0.1 here just to show it to you. And then GlimNet can also penalize in two different ways. It can do something called ridge regression, and it can also do something called lasso regression, or it can do some mixture of the two of them. And so by saying mixture equal 0.5 here, I'm going to say give me a 50-50 mix of the lasso or the ridge penalty and a 50-50 mix of the lasso penalty. And so these are just things that you would have to figure out which one work better and which ones don't. And also know if you've ever used GlimNet or seen it, we're avoiding a lot of jargon here because in GlimNet they call these lambda and alpha. And so unless you're like reading up on the statistical literature in the original papers, like the help file tells you that, but if you look at the function definition and it's lambda, it's like, what is that? So we try to, as much as possible, avoid jargon, whether that's a Greek letter or something that's just really specific to that package. We try to keep all the names the same of arguments and try to avoid sort of like things that maybe people wouldn't know what they are by looking at them. All right, so we know what we want to do and how we want to do it. So let's actually do it. Now we have a recipe that's gonna process our data and give it in a format that we want to GlimNet. And so we can do that in like a couple steps, but the best and probably most straightforward thing you can do is to combine them together in something called a workflow. And if you've ever seen like a scikit-learn pipeline, it's basically the same thing. We're basically binding a preprocessor, which is the recipe, to a model and use them as one unit. So by adding the model and adding the workflow or adding the recipe into this workflow, I can do everything with this one object. So if I want to fit my training fit my model to the training set, if you just use this with the workflow, it processes the recipe the way it's supposed to. It knows what the predictors are, it knows what the outcome is, it knows how to hand it off to the modeling function. And then the modeling function knows, oh yeah, GlimNet needs a matrix, so we're going to make sure we give it a matrix and does all the things that GlimNet needs. And then just as easily, the predict method is one simple step. You can, we're just predicting the first 5 rows of the validation set here, and you can see it comes back as a tibble. Most modeling functions will give you back a vector, unless you're doing multivariate, in which case it's probably a matrix, or if you're doing classification, sometimes it's vector, but sometimes it's a matrix if you're getting probabilities. And the point I'm getting at here is we want everything in data frames, even if it's a data frame with a single row. Because you can very easily just bind calls this to your original data. You can, do a lot more with a data frame if you're into the tidyverse than you have getting output out. You don't know if it's going to be a vector or a matrix or a data frame. So we always do everything with data frames. And the naming of these things is very consistent. So you'll always know the names of what you get out. Now, what I could do now is if I wanted to see if this model works well in the validation set, I could predict the entire validation set, C-bind that to my original data where the outcome is, and then I can look at one of the Tidymodels functions that computes like the root mean squared error and do all that. But we don't want you to have to worry about that. We have a suite of functions that do that. I'm using validation as like a single resample. So the code that you see here is the same code that you would use if you're using cross-validation or time series resampling. What you do is basically it's called fit resample. So we have a single one, and you just give it your resampling object, which we defined early on, and the workflow, and then it'll just fit whether it's 10 models for 10-fold cross-validation. It's just one for this validation set. It'll do that for every tuning parameter value you have. We only have one right now. And then get the predictions on the right data, compute the performance metrics, and give those back to you. So by running these like 3 lines of code, you get an object back, and if you want to get the performance metrics out of it, you can see here the 2 that come back automatically. The root mean square here is about 2.3 minutes, and the R-square is about 88%, which is not bad, right? You might be like, wow, that's pretty good, right? But as I said, the only way to be comfortable with your data is never to look at it. So we've also developed a bunch of calibration and diagnostic functions for a lot of models in this package called probably. So if I load the probably package, there's a function called cal plot regression. There's a bunch of cow plot methods, and that just does the observed versus predicted and keeps the axes the same and a aspect ratio of 1 die, and then it puts a little smoother on there, and you can see that actually the fits are pretty good unless you're really going to take more than 40 minutes, and then we're really, really under-predicting the data. So that R-squared of 88% might look pretty great, but maybe not once you look at this. So you might want to add some more features, and you might try a different model to figure out how you can do better on this. But the statistics don't always tell the entire story. So what about parameters? I keep talking about tuning parameters. So at this point, I might say, well, maybe I need 10 degrees of freedom for the spline, or maybe I should use a lower penalty or a mixture. At this point, what you can do is you can mark all those things for tuning and then use our tuning machinery to optimize those values to get like the lowest root mean squared error. And we're going to do that, but we're going to actually talk about a different model really quick. I'm kind of running late, so I'm going to go through this a little bit. There's this amazing model that not many people know about called Cubist. And it's been around for quite a long time, and it's a little bit like a boosted tree ensemble. What it initially does is it creates a regression tree. In this case, I've made a really short regression tree on this data set. You can see there's 4 terminal nodes. And what a rule is, it's a distinct path through this tree. So this is a model with 4 rules in it. So what Cubist does is it gets these initial rules, and then with each one of these data sets at the end, it fits a linear regression to it. So now I have 4 linear regressions from my model. And then, like boosting, it builds a sequence of these models together where at the end of this ensembling process, you might like have 100 rules. And you go to make a prediction. That prediction might only matter to like 20 of the rules. It gets their linear regression predictions, and then it averages them. And it's a very, very effective model. And if you were wondering what these rules look like, in this particular case, here's a rule where the order time is less than about 14 minutes. And if it was on a Friday or Saturday and it was within, let's say, 5 miles, then you should predict it using this model. Or if I had a longer running order, or I'm sorry, it was later in the afternoon on a Saturday, I think you should use this model to predict. So in Cubist, you get like maybe a subset of the total rules for every prediction. It makes a bunch of linear regression predictions and averages them together, and that tends to work pretty good. But we don't know how many things we should be averaging. We don't know if we should just do a little or do a lot. And so what we're going to do is tune that. So that model is available in one of our packages called Rules that has a bunch of rule-based models. It's called Cubist Rules, and then the variable that is the ensemble size is called committees. So I'll mark that for tuning. Cubist is easy. You don't have to do any indicator variables. You don't have to do any transformations. You don't have to, I think it deals with missing values. So I'm just going to give it, instead of a recipe, I'm going to have my workflow take a formula and then go on my way. So I'm not going to tell it how many committees to use. I'm going to say I want 25 of them, and you just pick ones based on everything you know about this variable, this tuning parameter. So instead of fit resamples, I'm going to use grid search, but the code is almost identical to what we did before. And it's going to use that validation set and training set. It's going to do this for 25 different values of committees, measure performance using the training set, and give you the metrics back. And when it does that, it looks like, looking at it, it's like, oh, it wants a lot of rules here. And the RMSE is, I'd probably say substantially lower, not massively lower, but it's an improvement on the linear regression model. I can auto-plot that and see what that trend is. Well, it turns out that we don't actually need this many. We could probably do with like 10 or 12 and get a simpler model and probably get about the same level of performance. So then, so now I think I know what kind of Cubist model I like. If you plot this, the data points, you can see, oh yeah, I like this better or whatnot. Spoiler alert, this is a better model. And then we have other machinery that I'm not going to go into too much, where you can finalize that model, say, oh, give me a Cubist model with 10 committees, and then we have a nice function called last fit that it'll take that initial fit, it'll run the model on your entire training set, fit the testing set, and give you the data for plotting and the metrics in one easy step. So that's like the gist of what Tidymodels does. I'm just trying to give you a flavor of like what the interface looks like and the ways we think about this. If you're just doing something super simple, like empty cars, you might just stick to LM and nobody here is going to be offended by that. It's not for like I need something really complicated, but there's things you want to do that are just kind of a pain in doing them in base R or in the packages. So it's really designed to help with that a lot. So there's just some links here to things in the Tidymodels book. I have like 2 minutes. The things that we've done recently is hopefully before the end of the year we'll release all of the packages that have the integrated survival analysis. So you can do everything we just talked about using like proportional hazards models or tree-based models for sensor data and so on. We spent a lot of time. It turns out case weights are really complicated, and nobody really knew that. So we enabled that in a lot of places for Tidymodels. And I just spent a lot of time decoding what these things are called conformal inference tools. So those are in probably, the things we're working on right now is model fairness metrics and ways to build your models to sort of mitigate any fairness issues. If anybody here does causal inference, we have some sort of prototype causal inference tools. So if you're interested, let us know. We'd love to get you to look at those. And then one thing we want to do is post-processing. If you want to calibrate your model or optimize the probability threshold to say whether something's an event or not, we have a list of things that we want to allow you to do or even optimize that come after the model fits. We have pre-processing the model. Now we have a limited number of post-processing tools that we want to do. And then, of course, the most important thing, thank you for the invitations to speak. Everybody today was sharing their mate with me. It was very nice. Like, the word got around was like, take mine. And especially thanks to the group. They do amazing work, including all the people who used to be in the group or have been interns or helped out. It's been a huge team project, and I really appreciate it. So, thanks.
Preguntas, questions?
Oh boy.
Thank you for your presentation. Tidymodels is really big, and I would like to know how, because in the process to do and compare models, you are doing a lot of steps, and you have different randomness in some point, and the models also have some randomness inside, and how you are thinking in the reproducibility when you are comparing different models that have different levels of reproducibility there. I know that you have something saying about here we have a problem about reproducibility, but I don't remember where, if you can explain that.
So the effect of like randomness on the models, the first thing I'd say is, that'll come out in resampling. So if you fit the model once and you don't know if it, and the model uses random numbers, you're like, was that a good set of random numbers? So, you can get the effect of random numbers by doing cross-validation. So that'll measure the effect of it. But the usage of it is, and we've inherited a lot of things that I really agonized and dealt with in Carrot. Like, I came in with a whole list of like, okay, we know what not to do, a few things. For a while, we had to figure out how, when you're running in parallel, to make sure you set the seeds inside the parallel workers to make sure those get set right. And I have to say that with one or two exceptions, everything's locked up pretty tight. That if you set the seed before you do like model tuning or something, in 99% of the cases, there's no issues with. Well, the problem is, like I said, R often farms a lot out to other computing languages, and the one, so there, I'll tell you about one that's well known. Is if you're doing a support vector machine, the main package that we use for that uses a C library called live SVM maybe, and it turns out that, I'm not sure why CRAN usually frowns on this. I'm surprised this is a thing, but it has its own random number generator in there. So if you're fitting a classification model, especially if it's one that has really low event priorities or event prevalences, if you run that model twice, you're going to get, you're always going to get different answers, but you get noticeably different answers in some case. So that's something external to us, and I've over the years emailed the maintainer, and they're like, we didn't write that library. But the other thing that we realized is with deep learning, we're trying to leverage a lot of what comes with TensorFlow and Torch. They do a lot on the GPU, and I'm getting the idea that it's really hard to set seeds in a GPU because none of them do it. So we try to lock that down as much as possible. In the R packages, talking to the people who manage those, there were ways to set it by setting like system environmental variables, but they've over the years given us ways to set that. So we've done as best as we can, But if chances are, if you're using a GPU, you can't really guarantee that that's going to happen. But I think for the most part, it's pretty solid in terms of reproducibility.
Anyone has more questions?
You mentioned that one of the possibilities when setting the engine was using Spark as an engine.
Yes.
I would like to know how transparent is the transition for the user when using a vanilla engine, let's say Random Forest, the more traditional implementation. If I want to switch to Spark, how much modification of my code do I have to do, or is more transparent? Is like I just switching the engine?
I've got good news and bad news. Which one would you like first? Bad news. Okay, bad news is right now in Tidymodels, you can only just fit, like with Parsnip, a Parsnip model with Spark. You can't tune them or resample them. And the reason for that is Spark data frames are really good at what they do, but they're kind of hard to program against. So for example, a Spark data frame doesn't really have a way to tell you how many rows are in it because you'd have to evaluate it to know. And in some cases, we need to know what that is. So I think if you're using Spark, is there anybody else here that uses Spark a lot? Okay. So if it's of interest to you, what I would suggest that you do is you go into like Parsnip and put in issues about, or the Tidymodels package or something like one of our repos and say, we need more comprehensive Spark support. So the bad news is, you can't do a lot with Spark and Tidymodels. The good news is it's really easy to know when that transition happens because there's no transition. So there's somebody who works with us a lot named Edgar Ruiz, and he's like the Spark genius. He probably knows more about Spark than most people on the planet. And I think he has grand designs for how you could make Spark work in almost everywhere in Tidymodels. The problem is that complexity, we don't know how many people, we don't know what the denominator is, right? Or we don't know what the numerator is. We know how many people roughly use Spark, but we don't know how many people out of that want this. And it would be quite a lot of work, especially for him, and we don't know if it's something we can do. So if there are people out there that would like something like that, you need to be vocal about it to us, yes.
Yeah. Can I give you feedback about that topic?
Absolutely.
In my organization, I think it's a chicken and egg problem because that idea will be more developed, like being able to code a model with a simple implementation and then exporting it to Spark. It will be like a killer application for many organizations because even for people who use Python, scikit-learn, coding in scikit-learn is very easy, but then transitioning the code, recoding that scikit-learn model to Spark, it's more complicated. So that kind of portability will be very attractive. I didn't know it was possible until you mentioned it now.
So yeah, there's some limitations though. So for example, let's say you need to impute data. Like you have missing data, and you need to build an imputation model into your preprocessor to predict the missing values. Like if you're doing like nearest neighbor imputation, now you've got to save the entire data set at that point in the recipe, say. So there's things that I'm not sure they're even feasible to do even if we try in Spark. So if we end up having more substantial Spark support, we don't know how to do this quite yet in documentation. We're going to need to tell you when you can use this and when you can't. I mean, we can have the function tell you, but when you execute it. But we need to figure out where that boundary is and how to document that boundary so that you're not frustrated. Like you see there's a recipe step to do something and it turns out it doesn't do it and it gives you an error. We're not really sure how to organize that. And yeah, we have this problem with data.table. We have the same thing with Arrow. Like in some cases, outside of the Spark modeling functions, all that has to be converted to a data set at some point, or a data frame at some point to use in standard R libraries. So this issue of like the data storage versus the training set in the model is a really tough one. But I know we can do a lot more with Spark. Yeah.
We have another question here.
Thanks, Max. One thing that I really like about the recipes part is generalized additive models, GAMs.
Yes.
I found that really hard to teach GAMs, but now I find it easy because I say, this is actually what it's doing. We put the smoothers in the, or the splines in the recipes, and then you can actually inspect them when you get your model results as well. But the thing that I struggle with recipes is a lack of feedback on what's happening at every step.
Yeah.
And a lot of these things are really vital and can be critically damaging to your data prior. So it's a little bit black boxy.
Yeah.
I'd like to have more diagnostics come out from each step.
So if you're just, so, you know, I used a recipe in a workflow, and I said fit and, you know, predict, and all that stuff just happened, which is opaque. If you're using a recipe directly, the function that estimates the recipe has like a logging, it does have a logging process that you could trigger, and it'll tell you, especially, it'll tell you like this many variables went in, this many came out, I eliminated these. We should definitely try to add that option during like resampling and fitting. So we would just need a way to, we have a mechanism, we'd have to add that potential for that flag to go through to the actual recipe execution. You're not the first person to say that. So yeah, that's something that we could definitely do. Yeah, I'm pretty sure we can do that. Yeah, I mean, it can be done, but it just depends on how much Emil is gonna regret it. Yeah.
So we have time for one last question.
Hi. In the documentation in the parsnip find models, later or a few months, a year ago, there is one option for a model. Linear regression. Right? In one page, we saw all the engines. Now there each engine. Yeah, I think users that don't know what engine do that need one extra page. So when I want to use a new model, so I go to find parsnip. I see several pages, so I don't know what to do. I think there was useful one page that this engine is for that. When you want to do that, congratulations, it's a very nice package. We are huge fans.
Thank you. So actually, do you want more information on like a description of how the model works, like the math of the model, or how to use the code, or what more would you like to know in that instance?
For example, sometimes there is in linear regression, there are very engines. So, what engine I have to choose in what thing I decide what engine to use if I don't know what to do each package. Yeah?
Okay. Yeah.
Yeah. So a page saying that is what useful.
Okay, so you would like more guidelines.
Yes, more information about the engines, what the engines are doing to, like, if you don't know about the methods,
Yes.
and you are learning something, maybe it will be helpful to have what the engine is doing and what kind of models are kind of.
Right. So I personally hope in the next coming year I'll be writing a lot more public web documentation on how these models work, like in kind of detail. Before that happens, so here's what he was just describing. He comes out to the Tidymodels, and I'll just pick this one because we just looked at it, and it's the first one. You can search here for the type of model we used. Actually, I'll look for Cubist. Okay, so Cubist, it tells you what package it is, what the engine name is, and there's a little link here. And what the link does is it takes you out to what we call the engine documentation. And the things that so did you get here?
Yeah.
Okay.
One step before.
Yeah.
We saw several engines.
Yes.
We need to do several clicks and too much information
Right. Okay. So you need something before this to sort of steer you. Okay. Okay. Hannah's got an idea.
Can you show the parsnip reference page and then?
That's this?
No.
Oh, do you mean like the linear reg one? Or?
Yes.
Okay.
Just for the model definition.
Right.
Because it lists the engines.
Yeah. Let me open R and do that.
You can just go to parsnip.tidymodels.org.
This is what I live with.
This is what he pays me for.
That's right. I pay for this. Oh my God. Yeah. So let's talk about linear regression, and I'm going to blow this up so it's really huge. So if I do like linear reg, so if you're not at the website, if you're in R, here's the main page that lists all the myriad I didn't know it was that many for linear reg. One nice thing is it tells you what packages, like this requires an extension package. This is the page you were looking for, Hannah? Yeah. Yeah.
It still exists on the parsnip page.
It does.
So if you're in parsnip and you click on reference, it lists you the model definitions, and then if you click on, say, linear regression, you get to that on the package downside as well.
We could fake that table out and say, like, make an artificial all engines and have it just link to this. Anyway.
We will try to put many ways to the right thing.
We should open up. We
So
should just do it
you
now.
end up at the right place
Let's
wherever
come on,
you start.
everybody. Let's make a pull request. No, we're not.
Okay,
that's really good feedback. Yeah.
If I a newbie in modeling, I saw linear reg, and there is many engines. So we, as error user, we know which engine choose, right? Yeah, but a newbie know. So I think it's confusing, more too much lines.
One other thing I'll show you that might help in the future is I'm going to go to the Tidymodels book, so the website for the Tidymodels book, and in there we have a nice table. It's like an appendix that if you're going to fit one of these models, like you might be wondering, like, wait, do I need to center and scale? Do I need to impute? And so we like have a table here that gives you like the list and says like, yeah, you should definitely need to create indicator variables for this, and definitely need to maybe normalize some things. So that can all, it's not a model thing, but it's like what you, even before you get to the model, you'll kind of need to know this, and it's not obvious sometimes. We put some of that in the engine documentation, but this is a very helpful link for you. Yeah. Okay.
Okay, thank you very much, Max. Ya vamos a empezar a terminar esto, así que te paso el micrófono.
Bueno, muchas gracias por haber estado todo este tiempo acá.
Feel free to get some power.
Bueno, ok. Se vienen momentos emocionantes del final, ¿eh? Muchas gracias por haber aguantado todo este tiempo. Aguantado no, digo, fue un placer, ¿verdad? Un placer. Estuvo, digo, para mí siempre me quedo con la sensación que quiero un poco más. Ahora estoy un poco cansada, pero estuvo bueno tenerlos acá, tener todos los invitados. Muchas gracias por venir, por estar, por participar, por seguir construyendo la comunidad. Pasaron muchas cosas lindas, vino mucha gente, vino Dayan, vino Max, vino Hanna, vino la gente de Epsilon que dieron cursos, vino Riva que también dio un curso, o sea, aprendimos, ¿sí? Y disfrutamos de la presencia de gente que viene muy lejos, que tiene mucha experiencia y eso también es muy bueno. Tomamos nuestra foto de Our Ladies, ahí estamos varias veces, porque hubo gente que no vino ahí. Y bueno, tuvimos nuestro momento de stickers, ¿no? Que es un momento muy estresante para la gente. Los vi peleándose y saltando así como locos. Bueno, y también algunos momentos difíciles, pero sí que está re bueno también ver a las amigas y pasar un tiempo juntas. Obviamente que esto requiere como mucho esfuerzo y mucho trabajo, ¿sí? Y básicamente con poco presupuesto requiere mucho más trabajo. Así que me encanta verlas a ellas, trabajar con ellas. Hace años que venimos trabajando en esto y tratando de construir la comunidad R en Latinoamérica y creo que estamos haciendo bastante bien. Y se va... Yo me pongo un sote. Nos ponemos un sote. 12, el máximo. Que ya no existe sote, creo. Es un 7. Bueno, nos vamos a bajar la nota un poco. Bueno.
Ok, me toca a mí. Sí, si se preguntan dónde estaba yo en la foto que ellas están llorando, yo estaba en la playa con mis hijos disfrutando. fui la más piola de las 3 chair, ¿vieron? Bueno, como siempre decimos, estamos hablando de comunidad, ¿sí? Y eso se hace con toda la gente que aporta su trabajo, su tiempo, sus ideas, sus ganas, sus energías a hacer esto. Así que muchísimas gracias de vuelta al comité organizador de este año. Nacho, Ignacio Álvarez Castro, Mauro Loprete, Andrea Gómez Varga, Beatriz Mills, Juan Pablo Ruiz Nicolini, el Tucu, Macarena Quiroga, Jessica Formoso, María Nanton, Roberto Villegas Díaz, Luis Pao, Elio, Patricia, Fabricio, Stephanie y Bruna. También muchísimas gracias al comité científico que nos ayuda a revisar todas las propuestas que ustedes mandan y decidir cómo vamos a presentar, en qué formato. Muchas gracias a Sara, Marcela, Ignacio, Virginia, Zulema, Naim, Elio, Jocelyn, Marina, Cristina, Paola, Juan Cruz, Andrés, Felipe, Alejandro, Denise, María, Adriana, Carolina, Juan José, Jennifer, Juan, Leonardo, Ricardo, Stephanie, Francisca, Felipe, Vilma, Germán, Gabriela, Alejandra, Inés y Luis. Un aplauso para todos ellos. Para todos los que están acá y se están preguntando, che, qué cool sería participar, sí, son todos bienvenidos. Muchas gracias a nuestros sponsors, a la facultad, al Instituto de Estadística de la Universidad de la República de Uruguay, al AR Consortium, a Epsilon, a CICADA y a nuestras comunidades amigas Our Ladies y Our OpenSci. Y muchísimas gracias al equipo local de la facultad, Laura, equipo de registro, equipo de informática, electrotecnia, comunicaciones, vigilancia y a decanato. Gracias totales.
Ya, ahora vamos a hablar del futuro, a mediano plazo, a largo plazo y a corto plazo. A mediano plazo, ¿qué sigue? Después de una conferencia uno sale con mucho entusiasmo, con ganas de hacer cosas y conocimos a muchas personas en estos días y la idea es mantenerse en contacto. Quienes no lo han hecho aún, únanse al Slack de LatinR. Entre las conferencias se mantiene muy activo, la gente comparte proyectos, comparte dudas, recursos, o sea, un espacio que se mantiene activo, no solo existe durante la época de la conferencia. También la comunidad de R en general ha sido muy activa en redes sociales, ese también es un espacio para mantenerse en contacto con las personas que conocieron hoy día. Y también están los meetups locales de Our Ladies, de los grupos de usuarios de R. Estos espacios, muchos de ellos estuvieron medios inactivos durante la pandemia. Espero que para muchos este sea el entusiasmo para partir. ¿Dónde está Claudia? Ahí. Ya estamos como haciendo que la gente empiece a organizar eventos. ¿Qué va a pasar el 2024? El 2024 vamos a hacer la conferencia en línea. Hay varias razones para esto. La última vez que lo hicimos presencial fue en Chile, el año 2019, y ese año una persona de academia, por inscribirse a la conferencia y a 2 tutoriales, pagó alrededor de $220. Este año, una persona que se inscribía de academia pagó $20 por la conferencia y pagó $15 por cada tutorial, o sea, el precio es mucho menor. Y eso es posible porque estuvimos varios años haciendo conferencias en línea que nos permitían juntar presupuesto para hacer la conferencia accesible. Este año, por primera vez, pudimos hacer que todas las presentaciones, el presentador o presentadora principal no pagara el ticket de la conferencia. Entonces, es importante, obviamente nos encantaría organizar la conferencia presencial todos los años, pero ese costo tendríamos que traspasarlo a los tickets para que la gente se registre. Y eso lo que hace es convertir la conferencia en algo inaccesible. Sabemos que existen muchas conferencias que tienen precios que son el sueldo mínimo de nuestros países y eso es inviable. Entonces queremos también hacer que la conferencia sea accesible y la idea va a ser ir intercalando versiones en línea con versiones presenciales para poder mantener los costos de una manera que sea viable para que las personas puedan participar. ¿Qué significa? Que el 2024 nos vamos a volver a reunir, pero nos vamos a volver a reunir de manera virtual y eso también le da la oportunidad a personas que no pueden viajar porque cumplen labores de cuidado, porque tienen trabajos que no les permiten viajar o por presupuesto, puedan también participar de esta comunidad. Entonces esa es una decisión importante a largo plazo. Respecto de lo que va a pasar el año 2025, que va a volver a ser presencial, queremos escuchar propuestas de a quienes les interesaría ser la sede de la edición 2025. Sabemos que ya hay varias personas en distintos países que tienen interés. Vamos a dejar un formulario en el Slack de LatinR y en la página web de LatinR para conocer su interés respecto de ofrecer su ciudad para que llevemos la conferencia a ese lugar y en 2 años más nos volvamos a encontrar de manera presencial. Y a corto plazo, el sorteo. Ya, tenemos varias cosas para sortear. Todo el mundo estaba preguntando por los stickers del Tidyverse y solo habían 2. Esos 2. Así que los vamos a sortear para que sea justa la distribución. Tenemos algunas, dependiendo de su país, remera, polera, sudaderas, que vamos a sortear también. Y lo que todo el mundo estaba esperando, la segunda edición del libro Art Packages, autografiada por ambos autores, Jenny Bryan, que fue Keynote Speaker en LatinR el 2018, y Hadley Wickham, que fue Keynote Speaker en LatinR el 2019. Así que vamos a hacer el sorteo con R. Tienen que estar acá, hay que estar acá. Así que me voy a mover hacia el otro lado.
Porque acá no están todos. ¿Qué sorteamos primero?
De lo pequeño a lo más grande.
Dale. De lo pequeño, vienen los stickers.
Redoble de tambores.
Llega, no era necesario moverse. Qué genial. El equipo de electrotecnia es fantástico.
Estás en el sorteo. Entra, Cris.
Ya, vamos. ¿Se van los stickers, Natalia?
Dale.
La función sortear. No, nos borramos. Joaquín Ferreira, ¿está acá? Al agua. ¿No dicen al agua? En Chile decimos al agua. María Fernanda González.
¡Opa! Otro más.
Bueno, se supone que tenía que sonar, pero no. Ya, vamos. El otro sticker, Roberto Aguirre. Al agua. Victoria Landaberry. Bueno, tenía efectos de sonido, pero no sonó, así que no importa. Ya. Valentina Cortés está por ahí. Ahí está. Carolina Muso se fue. Oh. Lucía. Lucía Tafernaberry. ¿No está?
No.
Mauro Lepore. Estaba, pero se fue. Ah. Emilio Aguirre. Ah. Daniel Araujo. Ah. Bruno. Bruno estaba por ahí. Bruno Tancredi. Oscar Montañez. No vino. Mayara Andrade.
No.
Negli Gallardo.
Allá.
Giovanni Reales. ¿Giovanni está? Ah, llegó justo para el sorteo. Eso es timing. Noelia Castellano. Se fue. Bernadette. Ahí está. Y ahora redoble de tambores. ¿Quién será?
Ay, qué nervio.
Wow. Santiago Nicoleta. ¿No está? ¡Oh! Federico Rodríguez.
No, ahí vamos a hacer el ruido.
Ah, ya, ahora sí. Con ruido. Valentín Ramanelli. Oh. ¿Sí? ¿Es él? Bueno, muchas gracias y nos vemos virtualmente el 2024 y en algún lugar de Latinoamérica el 2025.
Ahí está.